Question 10, we're going to state whether the function even has an inverse function. If it does not, explain why. If it does, we're going to find the inverse and state any restrictions on its domain using set builder notation. So how do we determine whether or not a function has an inverse? We apply our horizontal line test if we know what the original graph looks like. Well, the original graph shouldn't be too big of a stretch for us to graph because it's the parent function's the square root of x, which would look like this. It's plus 8, so we'd move it 8 units to the left. So we'd get a graph that looks like this, and then we would say, does it pass our horizontal line test? So the blue is my horizontal line test. Does this purple graph or pink graph pass our horizontal line test? Well, yes, it does. It touches in only one spot. So now we know it has an inverse because it passes the horizontal line test. So passes horizontal line test, which determines that the function is a one-to-one function, and all one-to-one functions have an inverse. So now I go about the business of finding the inverse function. So trade the f at x in for a y, the square root of x plus 8. To find the inverse, we trade the roles of x and y, so now it's the square root of y plus 8. And we need to solve this for y. To solve for y, we have to get rid of squaring first. So to undo square rooting, we square. So that means x squared has to equal a y plus an 8. Then I want to get rid of adding 8, which means we want to subtract 8, so it's x squared minus 8 equals y. And this represents our inverse function, f. So f inverse of x is x squared minus 8. Next thing we want to do is we want to talk about any domain restrictions that it has. Okay, so I want to remember what happens to a function and its inverse. So I'm going to come back up here and describe this purple graph's domain. So the domain of the purple graph would have to be every x value that is greater than or equal to a negative 8. Okay, we've done enough of those. I need to make sure that x plus 8 is greater than or equal to 0, which means x has to be greater than or equal to 8. The range of this graph, if I know a little bit about what the graph looks like, the range is all values of y that are greater than or equal to 0. So when we start talking about the inverse function, remember that the roles of the domain and range switch for the inverse. So now, if this is the function's f at x's domain and range, then f inverse of x has to have the reversed roles. So the domain and the range switch roles. Well, what we're after is what's the domain of this new inverse function? Well, the domain of the new inverse function will be the range of the old function, so it is simply all x's that are greater than or equal to 0. So yes, it has an inverse, and the domain restriction is all x values greater than or equal to 0. Remember the roles of x and y switching. That's for the entire domain and range. So domain and range switch responsibilities in the function versus the inverse function. Second problem here is f at x equals 4x to the 5th minus 8x to the 4th. And in order to get a good picture of this, what we want to do is we want to factor it out. So we're going to factor a 4x to the 4th. And we're going to be left with an x minus 2. Now, in factored form, polynomial functions are fairly easy to represent and graph and get a picture of them. So what I have is a graph that crosses the x-axis at 0. So 0 is an input that gives me an output of 0, and a positive 2. Now, we also have to recall that when it was raised to the 4th power, any even power is going to be tangent to. So this is an indicator saying that a graph is going to be tangent. Anytime it was an odd power, like a 1, it meant that it crossed or crosses the x-axis. And where this one is tangent to the x-axis. And then go back to our original idea. This is a 5th-degree polynomial, which is some type of an S shape. So it has to be coming from low to high since it's positive. It's going to be tangent and flatten because of the power of 4. And it's going to come down, and eventually it's going to come back up again to complete the shape of my graph. Now the idea is this thing have an inverse function? If it does, it would have to pass the horizontal line test. So I'm using this red line or pink line to represent my horizontal line test. No, it fails because it has a maximum, relative max, and min point, relative minimum point. it has a turning point, there can't be an inverse that's a function. So this one does not have, so there's no inverse function. It does not pass the horizontal line test as demonstrated in my picture now. It does not pass horizontal line test. So it is not a one-to-one function. And it's not one-to-one. There's not a unique output for every input.